So now we're going to graph that video of the Lego ball. And it says, the graphical representation to a situation may not be comprised of just linear functions. Watch the video and keep that in mind as we try to describe the motion of this ball in words and in our graph. Now we will focus on comparing the elevation of the giant Lego boulder over a time period from 50 seconds to 1 minute and 15 seconds. Sketch a graph comparing elevation, our dependent variable. Remember, dependent variable. The dependent variable is y, and then we have our time, which is our independent variable, x. So we're going to have time on the bottom. And then on the side, we'll have elevation. So I don't know the actual elevation of whatever city they're in. So I'm not actually going to put a scale on the elevation side, but I will on time. So we're starting at 50 seconds. I'm going to put a break in and do 50 seconds. That's that little squiggle. And then we're going all the way up to 1 minute and 15 seconds. So 1 minute is 60 seconds. 60 plus 15 is 75 seconds. And I'm just gonna go about halfway. So maybe we'll do 55, 60, 65, 70, and 75. Alright, so our ball starts off completely still. It doesn't have any motion yet. It hasn't changed elevation yet, but it's high up on the hill. So I'm going to start my ball high up on the hill, and as it starts to go down the hill, the elevation starts to quickly decrease. That was too far. So elevation starts to quickly decrease, and then all of a sudden the road is flat for a second. This is right about 62 seconds. The road becomes flat, and it's flat. It's not gaining elevation, it's not losing elevation, it's just flat. It's staying constant where it was. Then it goes down the second part of the hill, and it begins to quickly lose elevation again. And as the ball goes down the hill, once it starts getting like towards the bottom of the hill, it starts getting really, really quick, which is why these are curves instead of straight lines. Because as it goes down the hill, it gains speed. It's not at a constant speed. The speed it's going right at the top of the hill is not the same speed as it's going at the bottom of the hill. So I'm going to label these. So these little bumps is because the ball gains speed when going downhill, which is why it's starting to lose elevation quickly at the end of the hill. Then this little middle section here, this was the flat piece of road. So it wasn't gaining or losing elevation. And then this last section here, this is where the ball hit the minivan. Therefore, it was stuck. It was not going down, meaning the elevation had to stay the same. Alright, so let's look at the questions that go with this. Is the change in elevation decreasing at a constant rate? Well, we already kind of talked about this. At the very top of the hill when it's first pushed down, it's not going very fast, but once it gets to the bottom of the hill, it's really gained some speed. So we would say no. The ball, the Lego boulder, gains speed as it goes downhill. Next one says how many different functions make this graph and how many of them are linear. That's supposed to say linear, got cut off. So first, I'll kind of highlight them here. We have this first hill. Then we had the flat section. Then we had another hill. Then the ball hit the minivan. And it was flat again. So that was 4 different functions. So there are 4 functions. And it wants to know how many are linear. Remember, linear means that it has to be a straight line, no curves. The line can go up or down, that doesn't matter, but it has to be a straight line to be linear. So we had where the road was flat, highlighted in orange, and then we had when the ball hit the minivan and stopped moving. So that would mean 2 are linear. So this one was linear, and this one was linear. Alright, we're gonna keep moving on. A model rocket is launched from the ground. The graph shows the height of the rocket at various times. So we're gonna have height in feet versus time in seconds. So this is not speed, it's height of the rocket. Find the rates of change between points A and B and between points B and C. So I'll start with A and B. And then we'll do B and C over here. So our point A here is 0, 0. And point B is 148. So if I were to do x1, y1, x2, y2, because remember, rate of change just means slope, and that's y2 minus y1 over x2 minus x1. My y2 is 48. My y1 is 0. My x2 is 1. x1 is 0. 48 minus 0 is 48. 1 minus 0 is 1. So we just have 48 are units. So y units are feet. X unit is seconds. So this is 48 feet per second. For B and C here, B is 148. C is 264. So I'm going to label x1, y1, x2, y2. So y2 minus y1, 64 minus 48. x2 minus x1 is 2 minus 1. 2 minus 1 is 1. 64 minus 48 is 16. 16. So this is 16 feet per second. So which rate of change is greater? That would be the 48 is greater. So I'm going to say between points A and B, the rate of change is greater and all that means is that at first the rocket was going up really, really quickly because it was going 48 feet for every second. But then as the rocket got close to the top, it was only going 16 feet per second. So I would write something like, at first the rocket was ascending, going up quickly, but speed decreased as the rocket got to the top. So it was going up really quickly at first, but then once it got to its maximum height, it slowed down. Alright, just a couple of multiple choice now. This says which situation is best represented by the graph. One says a snowboarder starts at the bottom of the hill and takes a ski lift to the top. If you've been on a ski lift, you would know that they kind of move at the same speed the whole time, which would be a constant speed, a straight line. And this, you can tell that at first the speed is constant, but then like it gets really fast and then the speed goes back down. So I would not say that this is one, can't be one, because one would have a constant speed. A cruise boat travels at a steady pace from port to its destination. That's kind of like the ski lift. It's going the same speed the whole time. So not that one. An object falls from the top of the building and gains speed at a rapid pace before hitting the ground. So if it's gaining speed, that would mean speed is increasing, which it does increase from A to B and C. From A to C goes up. But when it hits the ground, speed like instantly is 0. So that would be, it would go up, but then it would literally just drop right down. So I don't think it can be that one because the speed goes down a little bit more gradually. This one says, a marathon runner starts at a steady pace and then runs faster to the finish line before gradually slowing after crossing the finish line. So let's see, section A here, that's our steady pace. That's why speed is staying the same. Then runs faster. So here, so this is steady or constant. Then B is running faster from B to C. And then from C to D, that's the slowing down part. So we're just trying to match to the situation. Alright, last one, and then just one to try on your own. Choose a graph that best represents each situation. A flag is raised up a flagpole quickly at the beginning and then more slowly near the top. So quick at first and then it slows down. So if we're looking at the height of the flag, if it's going up quickly, that means the height is getting very high really quickly and then is slowing down. So I would match that with C, because you can see here it's going really fast. The height is going up really fast, and then this is where the height slows down. It's still going up, but just not as quickly. 4 says a flag is raised up the flagpole in a jerky motion using a hand-over-hand method. So it goes up a little, then goes up a little more, then up a little more, up a little more. I would say that matches with A. The jerky motion here, it kind of shows like the starting and stopping of the height with each bump, how it goes up, then up a little more, up a little more. So that's graph A. And then 5, a flag is raised up a flagpole at a constant rate of speed. Remember, that means linear. If something is constant, that has to be B. Again, a straight line means it's constant.